All right, we're going to finish up the back side of this worksheet pretty quickly here, and I think I've got my graph for number 4 fixed up. So maybe you can compare your work to mine and make sure that we're in agreement there. So we've had 4 examples now using the translation form or the vertex form of the equation, where HK helps us get started and knowing the vertex right away given the form of the equation. Now we're going to practice a couple of examples using the root form of the equation. You know, standard form is what we're most used to, which is ax squared plus bx plus c is equal to f of x or 0, depending on what we're doing with our equations. So these are just 2 other forms that are useful to us depending on what we're given to work with. So as we look here, notice we've got y equals a. This is going to represent any stretching or shrinking that we do. And notice this is really just factored form. So r1 and r2 are going to be the roots of our equation, or in other words, the points that we will find along the x-axis. So as we look here, this is going to be root 1, this is going to be root 2. So that we know our roots are 3 and -1, and so we can plot those points immediately. Here is positive 3, 0 and -1, 0. Those are roots, and so we still need to find some other significant points. What we can do, though, now that we know these 2 roots, is understand that our axis of symmetry will be exactly in the middle of these 2 points. So a little bit of arithmetic, 3 plus a -1 divided by 2 will help me know where the middle is. So I'll be looking at 2 divided by 2, or the number 1. So right down through x equals 1 is where my axis of symmetry will be. All right, remember how helpful that is in graphing additional points. And we also know that our vertex will fall along that point. So that's going to make this point right here especially interesting for us. And notice I have already chosen some x values that are going to be around the roots and kind of complete the picture that we need. So as we continue on, the vertex is going to be at the position where x is equal to 1. So I could literally just say that 2 times 1 minus 3 times 1 plus 1, and do a little bit of simplifying here. So 2 times 1 minus 3 is a -2 times 2. So what we're going to end up looking at is -8. Of course, that's, you know, without going to our calculators, and we could have done that immediately, but that does help us to get our vertex pretty quickly without even using our calculators. But of course, you can get this whole list of points. Here we would have 0 and 0 because those are in fact the roots. So right here we have 3 very important points for our graph. And then 0, -6, and 2, -6 will also be points on our graph. So you could pause the video right now and take time to correctly graph and neatly graph your points from the table. And I'm going to use my axis of symmetry. Here we go. Putting that together. All right, so that's just using the roots to get started. We're going to do the same thing again in number 6. What would the roots be this time? Well, look right here. We're going to have what's called a double root. So we have 2 and 2. Really just one point of intersection with the x-axis. Notice again here we have a negative sign, so we're going to have a parabola that opens downward. So as I start already at the point 2, 0, Okay, that is what this means. 2 is the x value, 0 will be the y value. And so I'm going to seek out a few other points. Notice my table. Since my roots are 2, I chose 0, 1, 3, and 4 on either side of that value. All right, so you can pause and go to your calculator, put in the equation that we're working with or the function that we have here for number 6, and find your table values just like mine, which are going to be -4, -1, -1, -4, and 0. So the one, of course, that is most important to us is going to go through this point to 0, because that is going to likely be our vertex. All right, so to 0, and this is our vertex. All right, so I'm going to fill in the rest of my points. You can pause and do the same thing and then check to see that we agree. There we go. That's a pretty good representation. So check your work to see that you agree. And again, this is the root form where we use the roots to begin the graphing and then to find the vertex.